This video is to finish up example 3, or part 3 of this example regarding Tiger Woods and him hitting with his driver. We had answered questions 1 and 2 in class. So question 3, we want to know how far would Tiger have to drive the golf ball with this club to have the distance fall in the lower 10% of all drives. And we're going to follow the state, plan, do, conclude steps that we did in class. Just to recap, we're going to define the variable x. So x is the distance that the golf ball travels. And recall from class that we said this variable x follows a normal model with a mean of 304 yards and a standard deviation of 8 yards. We're going to draw a picture to represent what we're interested in. And so this is just recreating the normal curve that we had in class. So our mean is in the middle at 304. And then we have 312, 320, and 328 to go up to 3 standard deviations above the mean. And moving away from the mean, we have 296, 288, and 280. So we want to find where the lower 10% would be. And we know that the lower 10% would have to be somewhere below the mean. What I try to think of is the empirical rule. So to the left of one standard deviation, I have 16% approximately. To the left of the second standard deviation, I have about 5%, or 2.5%, excuse me, so that I know that lower 10% is somewhere in between that first and second standard deviation below the mean. So I just use that as my marker. And keep in mind that they've given us an area of 10%, which is represented by this portion that I'm shading in yellow here. So that represents the area that's 10% below the value that I'm looking for. So the only thing I know that connects to this area is a z-score. And so what I'm going to do in the next part is to find the z-score that corresponds to that. So this time I'm working backwards. Instead of standardizing x, I'm going to unstandardize z. So the first thing I have to do is find z where the area to the left is equal to 0.1. And if you look in the table, on the negative side is where you'll find it. You'll come across the number 0.1003, which corresponds to a z-score of negative 1.28. This is as close as we're going to get from the table to that z-score. So this is the z-score that we'll use. And then we'll go back to our z-score formula, z equals x minus mu over sigma. And we're going to plug in what we know. We know z, negative 1.28. We don't know x. That's what we're looking for. How far does this ball have to travel? We do know the mean, 304. And we know the standard deviation, 8. And so now what you're going to do is just solve for x. So x is going to equal negative 1.28 times 8 plus 304, which gives 293.76. And so then finally we'll answer that question in context. And we would say the golf ball would have to travel less than, because we want to be in the lower 10%. So we have to travel less than 293.76 yards to be in the bottom 10%. So this is how we use the normal table in reverse when we're given an area and we want to find a specific observation value. Certainly look over this, keep practicing with your website, and if you have any questions, be prepared for those in class tomorrow. Remember, the quiz has been moved to Monday, and I'll see you guys next time.